Hi everybody, this is Mrs. Richardson. Welcome to our Digital Learning Day video lessons. So for Algebra 1, we are going to be doing some guided notes on video, and if at any time you need to pause the video to catch up or to fill in any blank pieces in the guided notes can be found on Google Classroom. Feel free to do any of these things. Each of the teachers in the Algebra 1, I believe, are going to be doing a video help session or messaging, so just make sure that you are checking Google Classroom because that is where you can find all the information that we need you guys to understand while you are enjoying your time off and hopefully staying healthy and not getting the coronavirus. So let us start with Lesson 1, which is two-way frequency tables. So two-way frequency tables is basically just a way that you can categorize data. Up until this point, we've pretty much only talked about numerical data, and if you know the fancy word for that, that is called quantitative data. So that is our first blank. Quantitative data. And then that is kind of the opposite of categorical data, and categorical data is also called qualitative data. So quantitative just means something that you can measure. If it's anything that involves numbers, it's quantitative. If it's something that involves a category, pretty much anything, it's like a qualitative data, meaning it's a quality of something, or I don't know. Basically, it's just something that you can measure in terms of words as opposed to numbers. So we're just going to do a couple examples right now. If you want to pause the video and try it yourself and then see how many you get right, that would be awesome. If not, just follow along as I go through it. So number 1, it's asking if it's numerical or categorical shoe sizes of a basketball team. Well, we all know that we can categorize shoe sizes by numbers. So in that case, I would say that this is a quantitative data. So I'm just going to write quantitative. And then for number 2, favorite colors of students. So if we're talking about colors, I'll just start doing some highlighting too. If we're talking about colors, that's not something that you can measure in terms of a number. So in that case, we would be talking about qualitative or categorical data. Okay. Number 3, this one, the type of car. So we're not asked to see how many cars each employee drives. We just want to know what type of car they're driving. And in this case, that would be quantitative as well. Or qualitative. I'm sorry, qualitative. Or categorical. You could write that too. And then for the last one, it says elevations of the highest mountains. So elevation can be measured in a lot of different ways, but keyword, it's being measured. And so this could be in feet, it could be in miles, it could be in meters. Etc. And so in that case, if we're actually measuring something, then this is quantitative, or you can write numerical. So quantitative. The quantity of something. Okay, so next section. Now we're going to talk about univariate versus bivariate data. So univariate, think uni, like unicycle, you have one wheel. So univariate is one variable. That is one variable. So we're only measuring one thing. We're not comparing it to anything. Bivariate would be two variables. So in this case, we would actually be comparing two things together. So we're finding a relationship between two things, and then bivariate data is actually what we're going to be talking about for the next 2 lessons after this one. So that's pretty much the rest of your statistics unit. Luckily, we finished univariate before all of this chaos has happened, so we would not really need to go back and review that unless you need to. But bivariate data is what we're going to be focusing on for the rest of the statistics unit. So this is 2 variables. Okay. It says classify each of the following situations. So number 5, Mrs. Riley wants to see if her students' test scores are related to the amount of homework that they complete. So if you noticed, the key word in this situation is the word related. And the fact that something is related means we're comparing two things together. And so what are we comparing? We're comparing test scores and we're comparing the amount of homework that they complete. And so she wants to see if those things are related to each other. So the more homework someone does, maybe they do better on tests. We're not sure. So in this case, we would be talking about bivariate data. So two variables. Number 2, Ms. Crawford records the amount of time that she is spending each evening grading papers. So this is only one thing that she's measuring, so every single day, even though she's doing it multiple times, that would just be considered multiple samples of data. So we're not comparing it to anything. So in this case, we're only talking about time spent, so that would be univariate. Number 7, it says Ms. Wilson notices that there's a relationship between the side length of a square and the area of a square. So if we're talking about the relationship of something and it's side length versus area, then we're comparing two things together. So that would be bivariate data, just like the first one. Bivariate. And then finally, number 8, it says Ms. Schwarzenfeld records each of her lacrosse players' total goals for the season. So we are not comparing this to anything. We're not talking about, how many practices they've attended versus how many goals they've scored. It's only how many goals, the total goals for the entire season. So that would be univariate because we are not comparing anything. We're not finding relationships. Oops. So today we're going to be focusing on bivariate categorical data, and there is a specific way that we like to organize our information, and that is called a two-way table or a two-way frequency table, which we'll see in a second. So this is a two-way table. Okay, so that is slide number 1. Make sure that you have all of these notes filled in. If you're ready to go, then unpause your video and follow along with the next question. So we're at number 1. It says a teacher surveyed the students in the cafeteria and found that 25 males like skiing, while 10 of them do not. So we're still talking about male. 50 female students were surveyed and 30 of them disliked skiing. So if 30 people disliked skiing, we have to find out how many people actually liked skiing. So I've already filled in the table for you in terms of what they've given us in the problem, and they said using the provided information, complete the two-way frequency table below. Notice that the gender and skiing preferences are bivariate categorical data. So we're not talking about measuring anything, like I said before. We're only talking about categories. So in the first category, it's male or female, so it's gender. And then if we're talking about the columns, like skiing versus dislike skiing, that would be your preference. Do you like skiing or not? Neither of those things are things that you can measure with numbers. And so this is both categorical data and it's bivariate because we're comparing two things together. So we're seeing if there's a relationship between if male or female like or dislike skiing. Okay, so we don't know how many total students were surveyed, but we can do some basic addition. So if you look at dislike skiing, we know that 10 male, and I'll highlight where I'm at right now. So we know that 10 male like skiing and 30 females like or dislike skiing. And so in this case, we can just add the total up to find how many people total did not like skiing. So 10 plus 30 would just give me 40. So all I'm doing is adding the values up, and I'm just kind of going down this way. We can also do the same thing for male going horizontally. If we know that 25 male like skiing and 10 of them do not like skiing, that means 35 males were surveyed total. And then as I fill more of these blanks in, I can kind of now add more information into my table. So if there were 35 total males, we'll do some highlighting again. We have 35 total males. Oops. I'll do something lighter, maybe a blue. So 35 total male, 50 female. That means we know that there were 85 total students who have been surveyed. And then the rest of it you just fill out. If 50 of the female were total and then 30 dislike skiing, well then I can just do some basic subtraction and find that 20 of them like skiing. And then the same goes for total. So if 85 total students were surveyed and 40 of those students did not like skiing, then that also means that 45 students did like skiing. And then I can even confirm that by adding up the male and female. So 25 plus 20 is 45. So all these numbers should kind of work both directions, horizontally and vertically. If you add anything up, it should always total what happens in those dark grayed sections. And that brings me to the first section. It says that these cells that are shaded, those are called marginal frequencies. Marginal frequencies. And marginal frequencies, the way that I just remember it is if you think of a piece of paper, the margins are like the outside part of your paper, and so these shaded cells are all the outside sections. And then the non-shaded section are called joint frequencies because you're joining two things together. So those are joint frequencies. Okay. So now that we filled in the table, we basically are going to figure out what percentages of male, female, total students, who like skiing, who doesn't like skiing. So we know that there are 85 total people who've been surveyed in this survey. So in this case, 85 is actually going to be our denominator for every single one of the next cell parts. So for B, it says to better interpret data, we will create the corresponding relative frequency table. So this is relative. And it says to divide each cell, so we're dividing, by the total number sampled. So how many people were sampled? 85. That means that this can be represented as a decimal or a percent. So we can write it as a fraction to start, but then we're actually going to do the division in the calculator to see what the percent and the decimal would be. And the shaded section, again, marginal relative frequency, non-shaded joint relative frequency. So it's very similar to the first part. It's just we're adding that relativity, which basically just means that we want to find a percentage of people who like, dislike, male, female, whatever it may be. So for number 1, I'll do male. I'll do like skiing. Okay, so we're going to start off by doing, there were 25 males and there were 85 people who were surveyed. And so all you have to do is divide the two together in the calculator and then write it as a decimal. So I'm going to round it to 2 decimal places. And if I do that, you get 0.29. Okay, and then if I wanted to, I could convert that to a percent. It would be 29%. So all of these things are exactly how I just did it. For the next section of males who dislike skiing, there were 10 males, and there were 85 people total. If you divide the two together, you get 0.12, or 12%, whichever way you want to write it. It doesn't specify if we want decimals or percent, so it doesn't matter what your answer is in terms of its formatting. For total, 35 out of 85. This is very repetitive. And if I do that in the calculator, you get 0.41 or 41%. So I'm going to pause the video myself, and I'm just going to fill in the rest of this table for us just to save some time. Okay, so I just filled in the rest of the table. One thing that I did want to point out before I move on to the next slide is, I'm going to highlight it really quick, this right here. 85 out of 85. That means that at the end of every single one of your relative frequency tables, whether it be columns, rows, just in general a relative frequency table, it's always going to add up to 100% at the total end space. So that cell that I just highlighted in yellow, the 85 out of 85, that will always be 100%. If it's not 100%, that means we did something wrong and we need to go back and check our work. But that does make sense because we can't have 150% of students. We only know that we are, surveying 85 people, and so the final answer should be 85 out of 85 because that's all of the students. It represents the total amount of students that were sampled. So just make sure that when you are calculating this, you do end up getting 100% in that last final cell. Okay, so we're going to move on to the next section, which is question number 2. And it says over 1,000 students were asked what their favorite superhero was. So maybe we were talking about students at Centennial. I don't know. But only 450 of those responses were randomly selected. So we are given information, and I've already filled in what we know. So it says for the first bullet, 100 students chose flight. So they would want to fly as their superhero power, and 49 of the students were females. So I've filled that in right here. 49, 100 students. Then the next section, 31 students chose freeze time, and 71 of those 131 were male. So I filled that in the male column, and 131 total. So we're basically looking at columns right now. The rest of it you can read for yourself, but I filled the rest of the table in for us, and we don't need to fill those in. So now we are just going to complete the table based on addition, subtraction, whatever it may be. We know that there's 450 total students who were randomly selected out of the survey, so that definitely needs to be our last number, which I put right there. Okay, so looking at flight. If we know that 100 students were surveyed and 49 of them were female, that means that I can do some basic subtraction and get 51 male, because 49 plus 51 is 100, so that makes sense. 131 students and 71 were male in terms of freezing time, I'm sorry. And so in that case, if you do some subtraction, you get 60 female. And then for the rest of the table, invisibility, 75 minus 48 gives me 27 left over, so that's how many males. And then for super strength, there was only one other person who picked it because they must add up to 26. Telepathy, which is like reading minds, if you didn't know, 70 and 48. So those are both given male and female, and so now all we have to do is add those together, and you get 118. And then for the other blanks, in this last column right here, you have to actually add in this direction. And so I'm going to add up 49 plus 60 plus 48, basically adding all these up together, and then that gives you your total answer of 228 females. Okay, so I'm just going to erase this, make it look a little bit nicer. So 228. Okay, and if 228 total, you can do the exact same thing for male, add all of your numbers up horizontally, and then your final answer is 222. And just to make sure, because it only takes a second, I would add up these two numbers together just to confirm that it gives us 450, and if you do that, it does, and so we are in the clear. All of our numbers are accurate and they make sense for this table. And so now that we filled in our frequency table, we can just answer the next three questions. If you would like to pause the video at this point and try, great. If not, I'm just going to fill them in as we go. So A, which superpower was selected most often for females? So if you only look at the female row, this right here, then all you have to do is figure out which one had the most. And so if you look, 49, 60, 48, 1, and 70. 70 was the most, and so that was telepathy, which just means reading minds. Okay. Which superpower was selected most often for males? So now we're going to be looking at the next section. We'll do this one in blue or green, or this nice teal color. So for males, it is pretty clear that freezing time was the highest one for male. Okay. And then the last question is, which superpower was selected least often overall? And so it doesn't specify male or female, and in this case, we're actually going to be looking at the marginal frequencies, which is at the bottom. And so it's 100, 131, 75, 26, 118. The one that was the most is freezing time. The one that was the least was super strength. So that would be our answer. So super strength, because we want the least often. All right, so I think that this is kind of straightforward, so I'm going to move on to question number 3. If you are not finished with that slide, then just make sure that you pause the video, and then when you're ready, unfreeze and we can move on to question number 2B, I guess. So it's just the next section. So we're still using the same data that we did from this slide right here, but now we're going to be talking about relative frequencies. And if you remember, relative frequencies are the percents or the decimals. Okay, so in the question, it tells us that they want us to round to the nearest 3 decimal places. So for our situation, just make sure that's the thousandth. So we're rounding depending on those 3 decimals. All right, so for this situation, I'm going to do the first one kind of the long way, and then eventually when you guys get better at this, you don't have to write in every single fraction. You can just go right into doing it in the calculator and filling in your table. So for female and flight, we're talking about a relative frequency table, and so we should be dividing by the number of total responses that we got. And if you look at the top of your paper or the previous slide, it was 450 responses total. So that should be our denominator every single time. So 450. And how many students out of the 450 were female and chose flight? It was 49. So you divide the 2 in the calculator and you get 0.109. Make sure you're rounding. So that is kind of how you want to do these. I'll do the next one too, and then we can just kind of move on from there. So out of flight, 51 were male. So 51 out of 450. Again, it should always be 450. If we're not talking about a specific row or column, that's what we're going to do in the next section. So these situations, you're just dividing by the total number of people. And so if you divide that in the calculator, you get 0.113. Okay. So I'm going to fill in the rest of the table, and I'm going to pause my video. And then if you want to pause your video here too and try to do them yourself, and then you can unpause it and see if you got them right, great. Okay, so I finished the rest of the table. Just make sure that your values match mine. I rounded everything to the nearest 3 decimal places. So again, if you're not great at rounding, just look at the number after the 3rd decimal place, so the 4th decimal place. If it's 5 or above, we want to round up. If it's 4 or less, that means we want to just keep it as is. All right, so again, don't forget that this last value should always equal 1 or 100%, because these are decimal forms. We could have easily converted all of these to a percent, and that's what the next question is actually asking us to do. So it says, what is the marginal relative frequency for freeze time? So marginal means the grayed shaded cells on the outside. So we're going to look for freeze time, and that would be this cell right here, 0.291. Okay, and so how do I convert decimals to percents? You just move the decimal place 2 spots over. So 0.291, you move it 1, 2, and then that converts it to 29.1%. Okay, and then it also says write a statement interpreting what this means in terms of our context. So this problem, remember, is talking about what students prefer for their favorite superpower. So in our case, we had 450 total students, and that means that 29.1% chose freeze time as their favorite superpower. So 29.1% of total students chose freeze time. Oops. Okay, so 29.1% of total students chose freeze time. So this is regardless if a student is male or female. This is just out of the total amount of students that were surveyed. Per E, what is the difference in joint relative frequencies for male and female who selected flight as their favorite superpower? So I'm going to do my highlighter again. I'm going to change the color slightly. Let's do some pink. Okay, what's the difference for flight? So we are looking at this value and this value, and they look pretty close, honestly. So out of the 22.2% of people who picked flight, we had very, very, very close numbers for male and female. So 10.9%, and I'll write this down. So 10.9% were female, and it was 11.3%, I'm just moving the decimal over 2 spots, were male. And that's pretty close. Okay, so if I was to find a difference, you could just subtract the two. So it'd be 11.3 minus 10.9 if you want a specific number, but they're just really asking you to compare the two values. There was not a significant difference. So for F, it says, is there a noticeable difference for any of the genders and their favorite superpowers? If so, which one? And which would you say is the most noticeable difference? So the one that stands out to me the most is probably the superpowers. The super strength, because if you look at the super strength numbers from the previous slide, I'm going to go back a sec, you look and see that only 1 female chose super strength and 25 males chose super strength, so that to me is the most obvious choice. But if you look at invisibility, super strength, and telepathy, all of them are pretty significantly different numbers. They're all about 5% different from each other, so I would actually argue any of those things, but super strength is probably the one that stands out the most. So super strength because only 1 female versus 25 males. Okay, so that is a pretty significant difference. Other things that I would have also accepted would be maybe invisibility, because if you look, almost double the amount of females chose invisibility versus males. It was 6% versus almost 11%. For telepathy, it was 10% versus about 15-16%. So they're all about 5% difference, so each of those would be a fine answer. If you look at the other two, flight and freeze time, those values are not as significantly different. So moving on to the very last page of our notes. We have 2 more slides left. Hopefully this is a little interesting to you, since everybody seems to be obsessed with TikTok lately. I decided to create a little social media question. The two-way frequency table on the left represents the preferred social media of users of various ages. So we have kids, teens, adults, and then we have 4 different social media platforms. So we have Snapchat, TikTok, Instagram, and Facebook. Alright, so I gave you the table already. You don't have to fill any of these values out. So we're just going to analyze our information. And the whole point of this page is to compare rows and columns. Rows just mean that you're going horizontally, and then columns you're going vertically up and down. So the two-way frequency table on the left represents the preferred social media of users of various ages. That first blank is conditional. Conditional relative frequencies. It compares your frequency count to the marginal total. So basically, instead of it being out of the total number of students that were surveyed, you're only comparing it to the total in that row or column. Okay, so if we were talking about rows, again, this is horizontal. Okay, so if I go over to my table, those horizontal values would be 44, 55, 51, because you're going across from left to right. So all the kids would add up to 44, all the teens add up to 55, all the adults add up to 51. So that is how we are comparing our data. If we were talking about columns, on the other hand, columns can be measured vertically. Okay, vertical. So vertical is up and down. That would be talking about all the Snapchat users would be 31 total, all the TikTok users 56, all the Snapchat 37, all the Facebook would be 26. So we're going up and down when we're talking about conditional. Okay, so first example, again we are calculating decimals. So it says row conditional relative frequencies. I would very highly suggest that you highlight row conditional, because that means that we are going left and right. So what is the category that's going left and right? Well, that would be the ages. So it would be kids, teens, and adults. So in that first blank, we are going to write ages of people. Okay, so how do we do this? We are going to divide the frequency by the total for that row. So if you look, the total for kids was 44. It was up here, the 44. How many adults and teens? Teens was 55. So that's going to be our denominator for all of the teens. That would be right there. And then how many are we going to have for adults? 51. So all your denominators should be 51. So I did the first row for you, or the first column of the rows. So out of kids, if you look up here, 10 kids out of 44. And that's how I'm getting this value right there. Okay, so 10 kids, 44 total, and then you divide the two and you get 0.227. Okay, so I'm going to do maybe one more row, and then I'll pause the video and then fill the rest of it in. So for kids, we had 24 out of 44 kids enjoy TikTok. Not surprised. So 24 out of 44. And if you do the math here, we get 0.545. Okay, and then let's just stay with kids here. So again, we're going to have 44 total students, or kids. And how many of them liked Instagram? Only 8. So maybe they're a little young to use Instagram. I don't know. If you divide that in the calculator, you get 0.182. Moving on to Facebook, only 2 out of 44 kids liked Facebook, which is 0.045, which is only 4.5%, so not very many. And then these values is kind of interesting, will always add up to 1.00 or 100%. If you want to do these in percents, that's fine too. So if we're talking about rows, all of your total column here should be 100% or should be 1.00 because we're going horizontally instead of considering the entire table altogether. So I'm going to pause it here, fill the rest of it in, and then you guys can see how many you get right. Alright, so I finished the rest of the table. Again, just want to point out that all of these values right here should always be 1.00 or 100% because we are talking about horizontal rows and that would be the end of each row. So now the next section just says interpret the outlined cells. So I did bold one of the cells in the chart, and that's the one that's 28 out of 55 equals 0.509. So what does that mean in terms of this problem? So we're talking about rows. So we're only talking about the teens for that row. So what I would say for this is out of the 55 teens sampled, out of the 55 teens sampled, because that's how many total teens were sampled in the survey, 28 enjoyed TikTok the most. Or if we wanted to write it as a percentage, we could say 50.9% prefer TikTok. So out of those 55 teens, 50.9% prefer TikTok, or 28 of them prefer TikTok as their social media their favorite social media. So that's how we would interpret this situation. So we're not talking about out of the 150 total students, we're talking about only the 55 teens that were sampled. 50.9% of them enjoyed it the most. All right, so we're going to do one more table, and then that's it for this first lesson. Now we're asked to do literally the exact same thing, except now we're going up and down. We're doing vertical. And so in this situation, we're talking about these values right here. So we have to use the denominator as our marginal frequency that you're going to find in this section of the table at the top. So that's where I got the 31, the 56, the 37, the 26 for those denominators right here, here, and here. Those values all can be found from the very, very first table at the top of this page at the marginal frequency, which you can find at the bottom there. So let us fill some of these values in. First, let's fill in that blank. It says the condition of interest for the column. So what are the columns representing? Those are representing all your social medias. So all the different social medias can be found vertically. So the first one's Snapchat. How many teens liked Snapchat? Out of 31 people. So if you look at the table at the top, you're at 12. 12 teens. And I'm going to go back really quick. Right here. So 12 teens out of the 31 total. And then if you do the calculator, you get 0.387. The next section, still out of 31, because that's how many total people liked Snapchat. Only 9 adults preferred Snapchat, and that would be 0.290. 0.290, that's what I got. And then last but not least, we have 31 out of 31, and that is obviously going to equal 1.00 because that's everybody. So 31 out of the total 31 people who like Snapchat, that's just basically including all of your people. So 10 plus 12 plus 9, that adds up to 31. So those are the total number of people who liked Snapchat. We're going to do the same thing for TikTok, Instagram, and Facebook. So I'm going to pause it and then fill in the rest of the table. You can try it yourself as well, and then unpause it to see how many you get right. Alright, so there's the rest of the table filled out. Again, we're noticing that this right here at the bottom, they're all 1.00. That's because we are talking about columns. And so if we are going up and down, if you go to Snapchat and you go all the way to the bottom, that represents 100% of the people who like Snapchat. If you go to TikTok, you go all the way to the bottom. That means out of all of 56 people, 56 people are represented. So that's 100%. So each one of those marginal frequencies at the bottom should be 1.00 because we're going up and down. So it represents the end of each section. So we're interpreting the outline cell. That would be the dark one that's shaded. That's this one right here. So we are talking about Facebook because, again, we're talking about a column. And so we're in the Facebook column. So out of the 26 people who liked Facebook, out of the 26 people, and I say people because that's including kids, teens, and adults. So out of the 26 people who prefer Facebook, I'll just say FB, Facebook. What's the percent of people who are adults? 76.9%. That's quite a lot of adults. So 76.9% were adults. Because that is the intersection between adults and Facebook. So all the adults, all the Facebook. Here and here. That's where they meet. So we're talking about only adults. It's out of 26 people who preferred Facebook, 20 out of the 26 were adults. And so that as a percent is 76.9%. Okay, so that is the finished version of the very first lesson. Congratulations on finishing your first digital learning day. Classwork grade is going to be attached to the Google Classroom assignment, and so make sure that you go there and complete the Google form for lesson 1 because that is going to be the classwork grade to make sure that you understand what you're doing for two-way frequency tables. If you feel like you have any questions on this, your teachers, like I said at the beginning, are going to be holding informational sessions, kind of like tutoring, through Google Hangouts, most of us. So if that's something that you feel like you need, then just make sure you reach out to your teacher via email or maybe leave a message on Google Classroom's post. I'm sure you should be checking those things because all teachers are doing different things. So make sure that you are aware of what's going on for your specific class. But yeah, so you want to finish the Google form for lesson number 1. And then that will count as a classwork grade when you guys return to school. So congratulations, on to the next video.